Hi everyone, in this video we'll study longest common subsequence. And longest common subsequence is an important problem in algorithms and it's a very important interview question as well. So let's first try to understand this problem. So for this we'll consider character strings as a sequence of characters. So we can consider that we have two strings, x and z. So these are two strings or a sequence of characters. Now let x be abracadabra. Cadabra. Okay, this is the string x. Now let us consider another string named z, which is ada. Now z is a subsequence of x. Now why is this the case? Now you see a, if you consider the a in z, there is an a in x. Now if you consider the second a in z, you can move ahead and you can see that you could consider this a. If you consider this d, move ahead, you consider this d, consider this a, consider this one, consider the last a. So these 5 characters form the subsequence. So in the subsequence, you can only move continuously in one direction. You can't move back and forth. It's not like find whether these 5 characters are present in X. That's not the case with the subsequence. These 5 characters must occur in X, but they should occur only in that one direction. So you move all the way from left to the right. Another thing that you would have noticed is they need not be contiguous. So this is there's an A, then we have excluded the BR, then we have picked the next A, so on and so forth. Okay, so this is what is called a subsequence of another string. So Z is a subsequence of X because the Z occurs in X. Okay, if you remove some characters, so you'll get that subsequence. Okay, so now let us once again consider x. Sorry about that. So let us consider x again. So x here is abracadabra. Dabra. So this is what is x. And let's consider y, which is yabadabadoo. So these are two strings, x and y. Okay, so there are two sequences of characters. Now, between x and y, there are a bunch of common subsequences. Okay, for example, AB, A, ABA, this is one subsequence, one common subsequence. Okay, so this is one common subsequence. We can try and see if there are other common subsequences. Let me just erase this. So A, D, B, we can consider A, D, B. So A, D, B is another common subsequence. So you can find a whole bunch of common subsequences between x and y here. So let me just erase this. So there are a whole bunch of common subsequences. Now, our goal is, what is the maximum common subsequence or the longest common subsequence? So longest common subsequence. That's what we are first interested in, between x and y. Now if you consider x and y, and if you try to find out the longest common subsequence, that will be Z, which is ABA DABA. This is the longest common subsequence between X and Y. So let's see if that's the case, if such a subsequence exists. AB, if I AB, A, take this A, D, take this D, A, take this B, this B, this A, this A. Okay, so Z is the longest common subsequence. Okay, so the problem that we have going to study here is how to find the longest common subsequence. So that is the problem. Finding the longest common subsequence between two strings X and Y. Okay, that's what we are. Now, X and Y need not be of the same length. Okay, so X can be of size M, that is X1, X2, XM. So these are all the characters in that string of X, and Y could be of size N, that is Y1, Y2, all the way up to YN. So between these two strings, we have to find the longest common subsequence. Okay, so how do we go about solving this? Sorry about that. So we will use dynamic programming. So dynamic programming is our solution. If you're looking at this video, I'll assume that you have some idea of dynamic programming. I would go over this problem using dynamic programming, but I will assume that you have some basic idea of dynamic programming. If not, there is another video in this playlist which you can look at to study dynamic programming. Okay, so in dynamic programming, basically what you have is we have to find out, we keep track of the longest common subsequence in a table. Okay, so we'll do it in the table, and we have to first come up with rules to figure out how to fill this table. Okay, so that is what we are going to do. So to understand that, let us first consider the two strings. Okay, so let X equals BAC DB, and let Y equals BD CB. The LCS, or the longest common subsequence, is going to be BCB. Now, in dynamic programming, what you do is you build the solution slowly from scratch. That's what you end up doing. And you store the result in a table. Okay, so what does the table contain? Okay, so let us first understand the table. So we'll have a table like this. Okay. On one side of the table, you will have this. So I'm just going to have 1, 2, 3. So B, A, C, D, B. This is what I'm going to write on this side. And on this side, I'm going to write B, D, C, B. Okay, that's what I'm going to write. Now, these are the two strings, and essentially this is string X, which is of size M. So this is 1, 0, 1, 2, 3, 4, and 5. This is 0, 1, 2, 3, and 4. So we have a string of size 5 along one axis and a string of size 4 along this other axis. Now what do we get from this table? Okay, so let us assume that an entry in this table is denoted by Cij. So Cij is the entry in the ith row and jth column. Okay? It's an entry in the ith row and jth column of this table out here. Now, what will Cij store? Okay, or what does Cij stand for? That's the thing that we are going to study. Okay, now Cij captures the longest common or the length of the longest common subsequence between the true strings xi and xj. Okay, so let me explain that. Cij, it is captures the length of longest common subsequence between xi and xj and yj. Between xi and yj. So x is this one here, there is y, and what is xi and yj? So let us assume this block out here. Okay, so that entry is essentially C22. Okay, that's C22. This block out here is C43. Fourth row, third column. Okay, so that's what this is. Now, what does C43 stand for? Now, so in C43, you are finding the longest common subsequence between x4 and y3. That's what you are trying to find. Now, what is this x4 and what is this y3? We have just, so far we've just talked about x and y. So what is this x4 and y3? So x4 is essentially the string till the fourth character. So x4 is BACD out here, and y3 is BDC. BDC. So that's what y3 is. So what we are trying to do is we are trying to find out the longest common length of the longest common subsequence. That's what we are trying to find out between x4 and y4. So if we go back to this table, when we reach this place out here, this should give us the longest common subsequence. This entry C54 should give us the LCS of x and y. Okay, so that's what C54 that. So this is the important bit here. That's what C54 will give us. Okay, so now the goal is, when you have a table like this in dynamic programming, is to first fill out the values that you know. That is called initialization. Okay, so fill out, we'll start with initialization. That will be the first step. So I'm just going to write it. So first step is initialization. So first you'll initialize it. Then you will have some rules to fill the table. Okay, rules to fill the table. And then you will go ahead and fill the table, and hopefully when you get to the very end here, this point here, or this block here, you will find the longest common, the length of the longest common subsequence. Okay, at this point you might be wondering that if this table gives us the length of the longest common subsequence, how can we find the longest common subsequence? We'll get to that in a bit. But first, let's try to understand what this table is going to do. Okay, so at this stage, let's first draw the table again so that we can try to fill it. Okay, so this table once again is easy. We just draw it real quick. 5, 1, 2, 3, 4. So there will be B, D, C, B. It's B, A, C, D, B. And this is 0, 1, 2, 3, 4, 5. This is 0, 1, 2, 3, 4. Now what can you fill? What do you know? you know two things, that Ci0 is 0 and Cj0 is 0. Okay? Basically, the ith row and the jth column are both 0. So when the column is 0, you'll just go. So you'll have zeros here and you will have zeros here. So this is, it should be, zeros. Okay, so that's what we know. Now we have to fill this. So this is the basic. You start off with by filling what you know. Now how do we fill the rest of the table? Now this is the interesting case. Now to understand that, once you've initialized, we have to consider two cases. The first case is the last characters match. So let us look at this circle here. Now, when we're trying to fill that circle, we're considering the string BAC and BDC. Okay, and so we are basically considering X3, that is BAC, and Y3, which is BDC. Of course, we can't just start off by filling that space, but let's just consider it to understand this. Now, in this case, the last characters match. Okay, so basically the C and C match here. Now, when C and C match, or the last characters match in the general case for Cij, that is for Cij, if the last character xi equals yj, this will be the general case. Then what we can say for sure is this character will definitely be part of the longest common subsequence. Okay, so this character will definitely be a part. If there was another C preceding this, say in this y, the y, there was some C preceding this, whether you include that C or this C does not matter. So this C will definitely be a part of the longest common subsequence. Okay, so Cij, the length for the ith row and jth column, you can get that length of the longest common subsequence if you look at Ci minus 1, j minus 1 and add 1 to it. Okay, so just to understand, when you're trying to fill this circle here, okay, what you know is, you know these places already. Everything before it has been filled. So either we will move across in the row, or we will move across the column. But if you move across rows as well, you would have filled it. So these positions would have been filled, most of them. So when you're trying to fill that, bunch of things before that is known. So if you're trying to fill by columns, right? So we go move along this column, then we'll move along this column, we'll move along this column, then we'll move along here. So this has already been filled, these places. Okay. So when you're trying to look at Cij, you already know what value exists in this block. So some value for the longest common subsequence exists. So to get Cij, what you're going to do is you're going to get Ci minus 1, j minus 1. This is how I've written it. And you're going to add 1 to it. Okay. So you're going to add 1 to it and add that. So whatever entry is here, you're going to take that and do plus 1 to it. Okay. That is what will happen when last characters match. Okay. So the next scenario occurs when the last characters do not match. Okay, so let's look at that condition. Last characters do not match. So we considered the case where the last characters match. Now we are considering the case where the last characters do not match. Now the last characters do not match. Let's once again draw the table for our convenience. So we have the two strings as B, A, C, D, B, B, D, C, B, and there was 0, 1, 2, 3, 4. This is 0, 1, 2, 3, 4, 5. So the last characters do not match. Now, when we're trying to fill this block, okay, so the last characters don't match. So let's consider that we're trying to fill this. So we're looking at xi equals to BAC and yj equals BD. Okay, so we're comparing between those two. So the last characters do not match. Now, when the last characters do not match, one thing that we can be sure of is that both the C and the C here and the D here, cannot be part of the longest common subsequence. Okay, so both of them cannot be part. So what we can do is either we can try to find the longest common subsequence between BA and BD, which is this block here, or we can look at BAC and B, because both of them cannot be part. So when you're trying to fill this, we already know that these blocks have been filled. Either look here or here. Now, the Cij that we are trying to fill will be the max of C of I minus 1 j or C of I comma j minus 1. So we'll look at this value here and this value here. Whichever is the largest, we will just take that and put it in here, because that will be the length of the longest common subsequence. Because in this case, D and C and D do not match, so both cannot be part. So whatever was the value earlier, that's what we will put here. So considering all this, what we get down here is Cij, j, simple, will be 0 if this is the initial case, that is if I equals 0 or j equals 0. Okay, that's a simple case. That's the initialization. It will be C I minus 1 comma j minus 1 plus 1 if I and j are both greater than 0 and xi equals yj. And it will be equal to max of Ci comma j minus 1 and Ci minus 1 comma j if I and j are both greater than 0 and xi not equal to yj. That is the case. Okay, so these are the rules that we'll use to fill the table. Okay, so far a lot of the stuff that we have covered is how we go about filling the table. If you understand this, then you will be able to fill the table. So basically, when you implement this using code, you will basically code up this portion, these equations, okay, and that will help you fill up the table. Okay, now that we have realized this, let's go ahead and draw the table again, see how we can fill this up. Okay, so with these equations here. Okay, so we have once again B, A, C, D, B here, and we have B, D, C, B, 0, 1, 2, 3, 4, and we have 0, 1, 2, 3, 4, 5. Okay, and if I or j is 0, we are going to get all zeros in here. So we can put 0, 0. Note that this table at this point, we have only talked about how to get the length of the longest common subsequence. Okay, but soon we'll talk about how we can actually get the longest common subsequence as well. Okay. So now once you fill this, right, let's try to fill this block out here. Let's go by columns. We can go here. Let's just try to fill this block. When you try to fill that block, what do we get? We are looking at B and B. Looking at two strings, x1 equal to B and y1 equal to B. Okay. So those two strings have this last character to be the same. So we are going to look at the case where the last characters are the same, which is basically, I'm just going to write 1, 2, and 3. So we are going to look at case 2. Okay. So we are going to add 1 to Ci minus 1, Ji. So Ci, here we are, I is 1, I equals 1, J equals 1. So Ci minus 1, J minus 1 will give us zeros. Okay. So we're going to do C11 will be C00 plus 1. So you put a 1 in here. At this stage, we are also going to keep track of some pointers. The pointer will tell you which box this value came from. So essentially this 1 was filled using the 0 here, and that's why we are going to get the pointer there. Okay. Now, if you, we may want to fill this value. Let's just try to fill this one. Okay, you can go either by row or by column. It does not matter. Okay, so we want to fill that. Now we are looking at x1, b, and y2, which is basically bd. And we get to the case where the last characters, that is b in this case and d, they do not match. Therefore, what are we going to do? We are going to look at this column and this column and these two boxes, not the columns, but these two boxes. And you're going to take the max, which is essentially max of 1 and 0, which is 1. So you're going to put a 1 out here, and you're going to put an arrow here. Okay, I'm just going to take this eraser and erase this. Okay. So we put a 1 there. Now we can try to fill this one. Against it'll be basically between x1 equals b and y2 equals bdc. Again, the characters don't match, so you will look in this box and in this box between 1 and 0. Compare that. Of course, 1 is greater than 0, so you are going to take 1 out here and put an arrow like this. And if you fill, you will get to the state. So I'm just going to fill out these with the zeros as well. I'm just going to put the arrows so that it helps you understand. So this is how these arrows would be. And if you just solve it, you will know that this is the direction of the arrows. I'm just going to do it for ease of understanding. You'll get another. Now let's look at this box. Okay, so this box is x1 equals b and x4, and y4, which is bd cb. So, it's bdcb. So it's going to be bdcb. So the last characters match. Therefore, you are going to look at this box, which is a 0, and add 1 to it. Okay. So therefore, what are we going to do? It's going to be 0 in this box here, plus 1, which is going to be 1. It is important where you get the 1 from, because you are going to use the pointer to keep track of that. I'm just going to erase the first. So you're going to put an arrow pointing out here. In this way, we can fill the rest. So I'm just going to fill a few of those. There's going to be a 1 here, which is going to come out of here. There's going to be a 1 here, which is going to come out of here. There's going to be a 1 here, which is going to come out of here. There's going to be a 1 here, which is going to come out of here. Okay. Similarly, you're going to have a 1, which comes out of here. Another 1, which comes out of here. Now let's just consider this one. So this position. Now, I'm just going to erase these things. So we're looking at x3, which is BAC, and Y3, which is BDC. So we are at the case where the characters match. Okay, so we have to look, when you're trying to fill this box out here, you have to look at this box. Okay, because the characters match. So we are going to add 1 plus 1, which is going to give us 2. So I'm just going to erase this and also the circle. So you will get 2, and there will be an arrow pointing out here. The same if you look at this box out here, this one, that's the box that we're going to fill. Then we're going to look at x3, that is BAC, and y4, that is B or BDCB. Okay, now we just get rid of this. Now to fill that, the last characters, they don't match. Therefore, we are going to consider this box and this box. Take the max and put it in there. Okay, so once again, I'm going to erase the underlining. So we're going to take between 2 and 1, the max is 2. You're going to put an arrow like this here. Okay, now in this way, you can fill the rest of the table. I don't want to go on doing the same thing. So you will have 1 here, you can have a 1 here, and you will see that you will have a 2 here, which actually comes from here, and you will have another 2 which comes from here. There will be a 2 here which comes from here. There will be another 2 here which comes from here, and there will be a 2 here which comes from here. Let's just fill the last box. So now I'm just going to get rid of these this side. So what we are considering is x5, that is BACDB, and y4, that is BDCB. The last characters match here. So what we will do is, when we are trying to fill this box, we are going to look out here, that box. Okay, and you're going to add 1 to the 2 there. So I'm going to use the eraser to get rid of these. So this one. And so what we're going to get here is 2 plus 1, that is 3. So you're going to get a 3 here. And this is your LCS, okay, or the longest common subsequence between X and Y. Now, the next thing is, how do we get the longest common subsequence? We found the length. Now, here we are having a whole bunch of pointers that we've, and we are going to use these pointers. And when we use these pointers, we will be able to find the longest common subsequence. So we start from here. Okay? So we start from here, we're going to go this way. Then from here, we're going to go here. Just going to follow the pointers, and then I'll tell you how to use them. Go here, and you find the ways there. So those are your pointers that you're going to follow. Okay. Now, whenever you move diagonally, you are going to include that character, and you can pick either from the X or Y and include it in your longest common subsequence. Okay. So let's just understand that. So here in this table, when we move in this direction here, so B, you just take B. Now you move up, so you are not taking anything. Again, you move in this direction, so you take C. Here you're moving up, you don't do anything. Here you're moving horizontally. So either if you move vertically or horizontally, you're not going to do anything to that character. Again, you move diagonally, you include your B. So you start from this corner here and make your way all the way up. And as you get, you just output those sequences. So you go from B, go in this direction, then go up, then again go diagonally, then go up, again go horizontally, and go diagonally. Whenever you're going diagonally, you output those. So this is the table. This is the entire table. And in this table, what you have is even back pointers. So this is the LCS. What you have here is the LCS table with back pointers. And once again, if you want to implement it, simple. It's basically you have to implement equations 1, 2, and 3. Basically, those are the cases that you like to implement. And in your table, you will have to keep track of these pointers and use backtracking. Go back on these pointers, print it, and you'll get it your LCS. I hope this video helped you understand longest common subsequence, and I hope after this you'll be able to implement this algorithm on your own. Thank you for watching.